Now that you're fairly comfortable with the vocabulary of sequences, like the words arithmetic and geometric, and now that you're comfortable with the idea of the initial value, the term that kind of starts the whole sequence, let's try to put these ideas together in question number 25, the last question on this page. This question actually has 2, maybe even 3 tasks to have to think about. So let's break it down one by one. The first task is to fill in the missing terms of the sequence, which implies that we kind of have to do a little bit of pre-thinking. We have to figure out the pattern first so that we can fill in the missing terms. Then we have to classify the sequence as either arithmetic or geometric based on the type of pattern that we discovered. So that's why I said there are 2, maybe 3 tasks. The first task really is figure out what kind of pattern we see. So we'll start with letter A, and we'll think about the numbers that we're given here, 18, 6, and 2. Now all of those numbers have to have a pattern to them, and the same pattern has to be true to connect you from 18 to 6 and from 6 to 2. So while you can probably think of a few things that would connect you from an 18 to a 6, it has to be consistent, and the same thing has to also work for the next set and the next set and the next set. So even though I could think, for example, like, ooh, maybe I'll subtract. 18 minus 12 is 6, but 6 minus 12 is not 2. That's not going to work. So let's think about other operations. 18 and 6. Ooh, 18 divided by 3 would be 6. And 6 divided by 3 would be 2. So it actually seems like that would work. It seems like dividing by 3 should do the trick. So I'm going to assume for a second that the pattern must be dividing by 3. If the pattern is dividing by 3, that means I have enough information to keep the pattern going. 6 divided by 3 is 2. 2 divided by 3 is 2/3. Now, if you're not comfortable writing 2/3, you can definitely type 2/3 into a calculator, and you can do 2 divided by 3 and just get a decimal. 0.66666 repeating, you could call 0.67 if you feel more comfortable with decimal terms. That would be fine. Now, we have to keep going one more time. We have to divide by 3 again. Again, if you're comfortable with fractions, 2/3 divided by 3 is actually the same thing as 2/3 times 1/3, which is 2, oops, ignore what I wrote there, 2/9, my bad. And if you're not comfortable with fractions, you could use a calculator in a very handy way. Remember how we already had 2/3? If the pattern is divide by 3, I can simply tell my calculator to take that previous answer, divide by 3 again, and I'll get another decimal, 0.222 repeating, which we can round to 2 decimal places, 0.22. So it's fine if you write a fraction or a decimal. In fact, if I had converted my 2/9 to a decimal, I would have gotten that same 0.222. So it kind of works out either way. Nevertheless, we filled in those 2 blanks. Everything's looking good so far. Let's just think backwards then and see if we can figure out the initial value. If to go forwards through the pattern, I'm dividing by 3, logically then, think about how you'd have to go backwards. You'd have to do the opposite of the pattern. So if the pattern is dividing by 3, backwards would require me to multiply by 3. So I'm going to think now about 18 times 3. 18 times 3, if you want to use a calculator, is 54. And hopefully when you look at that number, that makes sense. 54 divided by 3 is 18, divided by 3 is 6, divided by 3 is 2, so the pattern definitely keeps going. It looks like 54 is a perfect fit. Now that we know all the missing terms, and now that we know we got all those missing terms by dividing, or in some cases multiplying, we can put a word to that. We know that any pattern that is generated by multiplying and dividing is called geometric. So where it says type, I'm just going to put a little G for geometric to indicate that that's the type of sequence that we're dealing with. This is the geometric type because it had a dividing pattern. Generally speaking, all of the questions in number 25 are just going to ask you to think in those same terms. What can you do to generate the missing numbers in the pattern? And then, how can you classify it as either arithmetic or geometric? I'll do one more with you just to make sure you have another example, and then I'll have you finish the remaining 2 problems on your own. In question letter B, again, think about your options for how to go from 18 to 6 and then from 6 to negative 6. I certainly am thinking again of dividing by 3 because 18 divided by 3 is 6, but 6 divided by 3 is not negative 6, so that doesn't work. Now 18 goes to 6, goes to negative 6. The numbers are getting smaller, so in terms of my options, I know that adding doesn't make sense. Adding makes things bigger. Multiplying doesn't make sense. Multiplying makes things bigger. So I'm thinking about subtracting now. What if we tried subtracting? 18 down to 6, I'd have to subtract 12. Well, 6 minus 12 is negative 6. It seems like subtracting 12 should work. So let's assume for a second that that really is the pattern. 18 minus 12 is 6. 6 minus 12 is negative 6. So let's keep going. Negative 6 minus 12 would be kind of like adding the two numbers together, negative 18. And negative 18 minus 12 again would be negative 30. That seems to work. That seems to be consistent. It seems to definitely make sense. And we know subtracting is a pretty legitimate pattern finder. So what if we went backwards? If we had to go backwards and figure out the term before the 18, let's think common sense. Subtracting 12 was taking us forwards through the pattern. So the opposite, adding 12, must help us go backwards. And let's think about what would happen if we do that. 18 plus 12 would be 30. Now let's pause and ask ourselves, does that make sense? Would the pattern still work if there was a 30 there? Remember the original pattern was minus 12? Well, sure enough, 30 minus 12 is 18. 18 minus 12 is still 6, and so on and so forth. It looks like the pattern worked perfectly. So now I know my initial value is 30, I know all my missing terms, and I know I had to subtract in order to generate this pattern. Because I was subtracting, or adding if I went backwards, I'm doing an arithmetic operation. So I'll write A for the type there to show that this is the arithmetic type. If that seems easy enough for you and you're willing to try question letters C and D on your own, this would be a great time to do that. I purposely am not spending a lot of time today going more into depth on any of these ideas because the first lesson is really just meant to kind of be an exploration, to dip your toes in a little bit, to get comfortable with the new words if you've never heard those words arithmetic or geometric before, and to just kind of play around with sequences, just to get familiar and to train your brain to think in pattern finding ways. In the next lesson, which is actually not even meant to start till next week, you'll be able to explore some of those things a bit more in depth. If you want to work ahead, you're welcome to do so. The whole packet is posted on the learning plan, but notice that the learning plan doesn't have anything specific after this lesson on Friday. Friday is meant to be our free play Friday, where you can do something that's totally unrelated and something a little bit lighter so that you can really just let your brain kind of chew on some of these ideas without rushing it. Next week, you'll begin page 3. Again, if you want to begin page 3 on your own, you're welcome to do so. You can check the answer keys and you can lead yourself as far into the future as you want to go. Just do so at your own risk, knowing that the next videos won't be posted till next week. In any case, take some time as you finish this last set of questions to make sure that the ideas make sense, to check your answers using the answer key provided in the learning plan, and to make sure you're in good shape. Once you know that you're in good shape, complete the quick check for today, and you should then be able to kind of close out the learning plan for the week, feeling like you've done everything you can do.